Imagine downloading a full HD movie in under 3 seconds. Imagine a video call so clear it feels like the person is sitting across the table from you. Imagine every room in your home, your bedroom, your kitchen, your study, receiving the same blazing fast, perfectly stable internet connection. Without a single dead zone, without a router struggling to push signal through walls, without anyone complaining that the Wi-Fi is slow. That is not a vision of some distant technological future. That is what fiber optic internet, brought all the way into your home and into every room, is already delivering to people. And the question for Ethiopia, for Africa, and for millions of people is, when does that become available to us, and what will it change? Welcome back to Technology in a Minute. Today we are answering when are FTTH and FTTR, fiber to the home and fiber to the room. How can these two technologies transform modern buildings and the everyday lives of the people who live and work in them? In our previous episodes we built a complete picture of wireless connectivity, from 2G and 3G through to 4G and 5G architecture. All of that is wireless, radio signals traveling through the air. But there is a parallel revolution happening underground and inside buildings. It is made of glass. It carries light instead of radio waves. And it delivers internet speeds that make 5G look slow by comparison. That revolution is fiber optics. And FTTH and FTTR are the two technologies that bring it directly to where you live and work. By the end of this episode you will understand how they work, and why their deployment in Ethiopia is a consequential connectivity investment. Let's start with the foundation, what fiber optic technology actually is, because understanding the physics makes everything else immediately clear. A fiber optic cable is a strand of glass, thinner than a human hair, that carries data as pulses of light. This single difference from traditional copper wire changes everything. Light travels faster than electrical current and does not degrade over long distances. Light is immune to electromagnetic interference, the kind that affects copper cables running near electrical equipment, elevators, or microwave ovens. A single fiber strand can carry multiple streams of data simultaneously on different wavelengths of light, a technique called wavelength division multiplexing. A single fiber optic cable can theoretically carry over 1 petabit of data per second. That is 1 million gigabits. To put that in perspective, a single fiber strand has the theoretical capacity to carry all of the global internet traffic simultaneously. Traditional copper internet is like a water pipe carrying data. The pipe has a fixed diameter, degrades with distance, and is affected by surroundings. Fiber optic internet is like replacing that pipe with a beam of light. The beam does not corrode or slow down with distance. One sentence verdict: fiber optic technology is a fundamentally different physical medium that removes the ceiling on what internet connectivity can deliver. Stay with me, because this is where FTTH and FTTR come in, and why the distinction matters for your daily life. FTTH, fiber to the home, means a fiber optic cable is run from the network all the way to your home's boundary. Typically, this connects to a box on your exterior wall or inside your front door called an optical network terminal, or ONT. Ethio Telecom has been expanding FTTH across Addis Ababa, replacing the copper last-mile connections that previously limited broadband speeds. Ethiopia's traditional ADSL typically provides 1 to 8 megabits. FTTH connections start at 10 and scale to 100 megabits or higher, but FTTH has one limitation. It brings fiber to the boundary, but inside the building, the connection hands off to Wi-Fi or copper wiring. Wi-Fi signals degrade through walls. In a modern household with multiple devices, Wi-Fi becomes the bottleneck that limits performance. FTTR, fiber to the room, solves this by extending fiber optic cable beyond the building boundary and into every individual room. Instead of one router, FTTR places a dedicated fiber-connected access point in each room, bedroom, living room, study, and office. This delivers full fiber speed directly to wherever you are, with no signal degradation, no interference, and no competition. FTTH removes the speed ceiling at the building boundary, and FTTR removes the speed ceiling inside the building. Together they create a connectivity environment where every device receives the full performance that fiber technology can deliver. Now let's talk about what FTTH and FTTR actually change for real people, real buildings, and real communities, because the human story of fiber connectivity is where its transformative potential becomes impossible to overstate. Start with education. because this is where fiber connectivity's impact on daily life in Ethiopia is most immediate and most consequential. Ethiopia has one of the youngest populations on the African continent. Over 60% of Ethiopians are under the age of 25. That generation is growing up in a world where education increasingly happens online, not just as a supplement, but as the primary delivery mechanism. The barrier that has consistently prevented students from accessing global online education is not lack of ambition, it is connection speed. Online learning platforms that deliver video lectures and interactive simulations require consistent broadband speeds that copper-based internet cannot reliably deliver. A student trying to stream a lecture on a 2 Mbps ADSL connection experiences constant buffering that makes learning genuinely frustrating. FTTH changes that completely. The fiber connection means for people in the same household can simultaneously stream high-definition content without affecting each other. The connection is fast and reliable enough that online education becomes a genuinely superior alternative for motivated students. FTTR takes this one step further. In a typical household, multiple family members need simultaneous connectivity for different purposes. Traditional Wi-Fi forces users to share one point, and signal degradation means the back bedroom has a worse experience than the living room. FTTR eliminates that inequality within the home. Every room gets the same quality of connection and equal access. FTTH and FTTR are also the connectivity infrastructure that makes smart buildings possible at a level wireless technology alone cannot achieve. A smart building is a building where dozens of systems are coordinated: access control, security, HVAC, energy monitoring, and medical equipment. Managing these systems with the low latency required for safety demands an infrastructure that Wi-Fi fundamentally cannot provide at scale. FTTR provides the backbone. When every floor has a fiber connection point, systems monitor devices with millisecond response times. In Ethiopia, the decision to install FTTR infrastructure during construction determines connectivity quality for the next 30 to 50 years. Buildings constructed today without FTTR will require expensive renovation. Buildings with it are ready for 5 decades of technology. Now here is where we have to be honest. FTTH and FTTR face genuine deployment challenges. The first challenge is infrastructure cost. Installing fiber optic cable is significantly more expensive than copper or wireless infrastructure. Running fiber through existing neighborhoods requires civil works, managing disruption to road surfaces and utilities. The second challenge is the last 100 meters. Connecting individual buildings requires landlord cooperation and complex permits. Ensuring new buildings are constructed fiber-ready from the foundation is more economical than waiting until the building is occupied. The third challenge is affordability. Uptake depends on subscription costs being within reach of the households it serves. Ensuring benefits reach middle-income families and small businesses requires pricing models and subsidy frameworks that make fiber adoption accessible. Building a connected Ethiopia is a collective effort, ensuring no one is left behind in the digital age. So zoom out for a second. What does understanding FTTH and FTTR actually mean for Ethiopia, for the buildings being constructed right now, and for the daily lives of the people who will live and work in them for the next 50 years? Here is the thread that connects fiber connectivity to every episode we have built in this series. We talked about the BSC and RNC managing mobile networks, the Node B and Node B delivering wireless broadband, the cloud computing infrastructure processing data at scale, the IoT sensors collecting information from physical environments, the blockchain systems moving value across borders, the ECX platform connecting farmers to global markets. Every single one of those technologies performs better, faster, more reliably, at lower latency, when the underlying connectivity is fiber rather than copper. The wireless networks we have discussed are essential for mobility, for connectivity that follows you as you move through the city. But fiber is essential for depth, for the quality of connection that enables demanding applications at fixed locations where people live and work. These two layers, wireless for mobility, fiber for depth, are not competing technologies. They are complementary ones. A city with excellent 5G and no fiber backbone is like a city with good roads but no buildings. The roads let you move, but the places themselves have nothing inside worth reaching. A city with fiber infrastructure is where every home is a workspace, every school a global learning platform, and every hospital has AI-assisted diagnostics. For Ethiopia specifically, the timing is significant. Ethio Telecom's FTTH expansion represents one of the most important infrastructure investments in the country's future. The fiber being laid today will carry the data traffic of 2040 and 2050 because fiber optic infrastructure does not need frequent replacement. The glass stays, the electronics at each end upgrade. A fiber cable installed today will carry technology that does not yet exist. The smart building dimension is urgent. Every residential tower and hospital under construction in Ethiopia is making a decision about its connectivity infrastructure. Installing fiber conduit during construction costs a small fraction of the budget. Retrofitting a completed building costs many times more and causes disruption. Developers, architects, and urban planners have a role to play in ensuring that fiber-ready construction becomes the norm in Ethiopia's built environment. Students in FTTH-connected homes can complete degrees online, accessing courses that do not exist within physical travel distance. Doctors in FTTR-connected hospitals can conduct AI-assisted consultations using real-time imaging data that requires consistent fiber bandwidth. Small business owners in fiber-connected buildings can run e-commerce operations that were previously only possible for large enterprises. Ethiopia's 5 Million Coders initiative and cybersecurity professionals need high-quality, low-latency connectivity to do their work effectively. A developer on a 50 megabit fiber connection with sub-5 millisecond latency is competitive with developers anywhere in the world. Fiber optic technology carries data as pulses of light through glass strands thinner than a human hair, delivering unmatched performance. FTTH Fiber to the Home brings fiber to your building, replacing the copper last mile connection that was historically the bottleneck. FTTR Fiber to the Room extends fiber into every room, eliminating Wi-Fi dead zones and bandwidth sharing inside buildings. You now have a complete picture of why the decisions made right now about fiber will shape Ethiopia's digital capabilities for the next generation. If that is the kind of understanding that matters to you, subscribe and turn on the notification bell to join our community. Next episode, we go inside AI and ask, when an AI system makes a decision about your health, how does it reach it, and who is accountable?